Hello, everyone. We will start the broadcast in a minute or so. We'll just wait for some people to join. Okay. Good morning, afternoon, and evening to all of you. Welcome to today's webinar titled Modern CAD Visualization Solutions. My name is Ajay, and I'm the moderator and host for today's webinar. I will begin by introducing our speakers. Our first speaker for today is Tom Gill. Tom is the practice manager, PLM Enterprise Value and Integration at SimData. He has over 25 years of experience applying computer-based solutions to engineering and manufacturing. Before joining SimData, he worked as an independent PLM consultant after spending over 20 years at high-volume manufacturing companies. We also have Sridhar Oruganti, who is the product manager of Glovius, and has worked extensively in designing and developing CAD visualization software. He started his career as a design engineer for a large engineering project for the government of India. He has a total experience of 13 years designing and developing software products. Our guest speaker for the day is Jaco Lagave, planning and project leader in the automation department at BRINK BV, Netherlands. Jaco started his career as a mechanical engineer for assembling machines for the packaging industry. He then moved on to the designing of these machines before taking over as the automation planner and project leader. Jaco and his team at BRINK BV use Glovius for their design, visualization, and collaboration needs. The agenda for today's webinar is as follows. Tom will begin the presentation and will share his insights on the current and future directions in CAD visualization. We will follow it up with Sridhar showcasing how Glovius addresses the visualization and collaboration needs. Our guest speaker, Jaco, will then give a customer's perspective of how Glovius is used. And then we'll follow it up with the question and answer session. Before I hand it over to the speakers, let me share the logistics of today's webinar. The webinar is approximately 60 minutes. We have kept all attendees in listen-only mode to avoid any background noise. We do, of course, welcome your questions during the presentation. In order to submit your questions, simply type in using the chat window on your GoToWebinar console. We will attempt to answer as many questions as possible at the end of the presentation. Please note that we are recording this session. We will send a follow-up email with a link to the recording early next week. So without further delay, let's begin with the presentation. Over to you, Tom.
Thank you, AJ, and welcome everyone. Thank you. So today I'm going to talk to you about CAD visualization and what are the best practices today and where we think the future is going. So first, I want to tell you a little bit about SimData. We are a strategic management consulting firm, and we focus solely on PLM. We don't sell software, and we don't implement software, so we maintain vendor independence. As far as our services, we have three primary legs to our business. Research, we do both market research and technology research. We survey over 500 companies annually and publish a series of market reports that all the PLM solution providers use to do their planning on which markets to address and which products to develop. In addition, we do technology studies, competitive analyses, and those types of things. Second leg is education. We have a PLM certificate course that's vendor neutral. We offer it to the public 4 times a year at various locations around the world and use that material in private seminars and also within our consulting. And consulting is the biggest portion of our business. We work with both solution providers and industrial companies, helping them to develop strategy and their plans to go forward. Again, we one of the big benefits of our consulting is we're vendor neutral. We have no vested interest in what solution is chosen, so we help our customers choose the best solution. So just a brief background to myself. AJ mentioned I've been with SimData, and prior to that I worked in industry. When I worked in industry, I started out as an engineer and then got involved with CAD software development, did some finite element analysis, and then finally moved into data and process management, what became PLM, and I was involved in implementing a global PLM system at a tier 1 auto supplier. So today what I'm going to talk about is CAD visualization. I'm going to start at the high level and talk about what you need to, what are the key elements you need to get business value, and then how it can support digital transformation programs, which is starting to get in the news a lot. I'm going to go down a level of detail and talk about what are the requirements, what are the capabilities that you should probably care about in a CAD visualization solution. And then finally, I'll go back up a level and talk about how you can, leveraging visualization, you can extend business value through your product lifecycle. So in order to get a robust visualization solution across your enterprise, what we've seen from working with our clients and working with the vendors is there are really 3 critical success factors. It needs to be, your solution needs to be cost effective, because you have so many people involved. If to properly implemented, a good portion of the employees in your companies will access the visualization tool, and that can be a lot of licenses. Furthermore, it needs to be easy to use. The creation of data with CAD software is complex, and the reality is you're not going to have people from sales and marketing and customer support wade through a CAD application to answer questions. So by having an easy to use viewer, you can make the access to that CAD data much easier, and ideally without training. You can deploy the solution and it will have enough discoverable capabilities and that people can use it without training, which saves time and money. And the last point that we find is platform independence. That might seem a little obscure at the moment, but for the last couple of decades, Microsoft Windows has really dominated the desktop. So most applications have been coded to Windows. But over the last few years, there's been some shifts in platforms with the mobile devices taking over, a lot of endpoint access to data. And so you need to make sure that your application can access those devices and devices that will be coming up in the future. So even though many people think visualization is settled technology, it's still a long and winding road ahead. So now we're going to delve in a little bit deeper and talk about some of the requirements that we see being of high value across our industrial clients. I'll be going to each one of these items in a bit of detail. Okay, so the reality is today it's a very heterogeneous world in most environments. Historically, people had a single CAD tool. The reality is it's now possible today to use MultiCAD or different CAD tools to create your data. It's very common to see CATIA and NX in the same environment, SolidWorks and many other tools, and designers collaborating, exchanging solid models between those systems. Beyond the CAD software, web browsers are a very common way to access systems. Some applications are still browser dependent, You've got Google Chrome and Firefox and even Safari if you move over into the Mac world. I mentioned previously about Microsoft Windows dominating, but you've now got iOS and Android on the mobile platforms. And we're starting to see a lot more access over cellular networks as 4G gets rolled out, and then the upcoming 5G. People will be able to access data using many, many different technologies and environments. So that many environments is a key point of why you need to be able to have some platform independence as companies migrate, change tools and infrastructure relatively often. So next point to talk about is assembly structure support. Modern CAD solid modeling tools that have been used for many years now generally build each part or each component as a separate solid model. It works well to subdivide the design so you can parallelize things. Different people can work on different components, and then the components are connected together in an assembly file, and that file is basically a series of pointers to other data. If you look in the image shown on this slide over on the left side of the screen, you can see a typical assembly file structure, and that structure captures the relationship, the positioning between parts. Today, a modern viewer today has to be able to deal with this structure. You should be able to open up the data and browse the structure, turn components and subassemblies off and on to get the view structured the way you need to see it to do your job. So the next most valuable capability is markup and analysis. Analysis historically has been done within the CAD software applications. And then higher end analysis is done with dedicated simulation tools. Because viewers now understand the solid model, the geometric properties of components and assemblies, you're now able to do basic and actually even some fairly advanced analyses within a viewer. You can calculate weights and volumes, mass properties, centroids. In the case of assemblies, when your assembly relationships are properly created, the viewers are able to manipulate the assembly constraints to give a basic simulation of how a product's components might move around. And then you need to be able to visualize non-graphic data that gets associated with components, attributes, product manufacturing information, which I'll talk about in a bit more detail in an upcoming slide. And beyond analysis, being able to analyze a design, you need markup capabilities. A big part of design is communication, and the more direct your communication is, the more efficient and clear it is. So if you're able to view solid model data, make measurements, associate dimensions and notes, and markup directly to that model, it can then be saved back to your system and shared with other people to make fixes or answer questions. So the one of the cool things we'll now move into the future and where we see it going, and in many ways here it is now. What we're trying to accomplish in the PLM world is get access to the right data to the right people at the right time. The underlying data management tools and structure management like assembly modelers segregate and control the data, but the underlying graphics is where the real value is. And the cool thing with today's technology that we're able to model in CAD systems, access in viewers, is the right kind of data for future access, whether it's virtual reality or augmented reality, like what's shown in the image off on the right. This data is becoming mainstream today, and so we're really looking forward to seeing some good use cases coming up in the future. So shift gears just a little bit here and talk about bigger picture trends and potential disruptors. If you follow the news at all, I think you understand at least some of the basic issues that are driving business today. You've got technology aspects, cloud and mobile, additive manufacturing, 3D printing are more on the physical side. The data that is starting to get collected from Internet of Things and associate with products as they operate is giving new opportunities for analysis to improve products and improve product operations. Most companies we talk to today have some sort of innovation program going on. They recognize that innovation is the path so you don't become commoditized and have to compete only on price. Recycling, environmental issues are driving a lot. And all this is being done, for the most part, without price increases. So companies expect more done with less. So if you want to click, and all these different aspects of design really add to complexity. And we are seeing the growth of complexity driving a lot of change in business today. Okay, so all those trends and disruptors, they're really giving companies an opportunity to rethink everything. If you can react to it and be driven to move ahead, or you can be proactive and try to move ahead on your own. And our encouragement to companies is that they really need to move ahead and take charge of their destiny. So I mentioned it earlier, product manufacturing is a key technology that has been developed in a proprietary fashion for quite a while now, but it's now moved into the realm of standards where product manufacturing information, or PMI, is available within the STEP standards, which most CAD-related software applications support. And it supports both visualization, viewing, and next generation manufacturing. So if you look in the image on the right, you can see some GD&T callouts that are embedded directly on the solid model. That's what the PMI standard is about. And what it enables engineers to do is, rather than adding tolerance information as a drafting operation after the design is done, they're able to encode the tolerances as the parts are designed. The benefit there is drawings can be automatically derived. There's a lot less need for fully detailed drawings because the data is stored on the model. And with the latest standard, your manufacturing software is actually able to consume this data and automatically generate some manufacturing operations. So we're very excited about that product manufacturing information is finally becoming mainstream. But a key aspect of CAD visualization is downstream users need to be able to view this data, to validate, to verify, to do their planning. So viewing technology needs to be able to support PMI. Next function that's really been a game changer that's emerged recently is compare. Historically, viewing technology has been able to compare 2D drawings. It used the plot file to do a compare on 2D geometry. But the latest technology is now, because it understands assembly modeling and the solid modeling, you're not only able to look at 2D drawings, you're able to look at 3D geometry and overlay one 3D part with another to see what's changed. And perhaps the most exciting part for products with any complexity is you're able to see parts that are added and removed. as this image shows. That's a huge benefit to anyone that ever has to validate bills of material. Instead of having to look at lines of text and part numbers, you're able to graphically see what's been changed in a product. So it greatly simplifies the communication of change and reduces errors and the cost related to those errors. And furthermore, works up and down the supply chain. Your suppliers can see what's changed, and which will help them reduce mistakes in their business operations. And so now we'll take a step back out to the higher level and talk a bit about digital transformation. This is a concept that's getting a lot of action in the trade press right now. And one of the areas we like to focus on is supply chain, making sure that your digital transformation incorporates a supply chain, because for many companies, that's where a lot of the value in their product comes from. All the different suppliers, and making sure that they have the right data to deliver the components that you need within your product. As PLM solutions are improving data access within companies and across companies, being able to share those 3D models, you're able to view data. A big change that we're starting to see, I came out of the automotive industry, and the legacy strategy there was to require the same CAD system of the supply base, which added a lot of complexity and cost to suppliers. And what we're seeing is that the viewing technology in many cases is good enough so that suppliers don't need a native tool. You're able to open the native files and then analyze them and make the components that need to be made. So that's a huge boon, and suppliers that we work with are very excited to take advantage of this. And even the OEMs are getting excited because they understand it can reduce the cost for their suppliers. So this helps with these modern visualization solutions that are able to open native data. It makes a much more cost-effective process, and then making sure that it's platform independent, so you're not dependent on a specific brand of technology or infrastructure, will make your digital transformation much easier to execute on. And so just to wrap up here, at the high level, you really need 3 primary attributes to make collaborative visualization work. You've got to have a cost-effective solution so you can get it deployed widely across your company. It's got to be easy to use so that those people across your company that are using it don't need a lot of training and they can just get their job done. And then platform independence. Make sure that you can support all the different technology platforms you have in-house and are prepared to be able to support the upcoming things like virtual reality and augmented reality. CAD visualization requirements can vary. I talked about the ones that we've seen to be very important. You need to be able to view, annotate, analyze, and navigate data. Those are the high-level core capabilities, and that you need to make sure your visualization solution has. And if you get involved in your company's digital transformation program, the visualization tool can be an important piece of that product. So that covers what I'm going to talk about. We'll take questions at the end of the webinar, and I'd like to turn it over to Sridhar now. Thank you.
Thanks, Tom. I guess we have attendees from different parts of the world. So good morning, good afternoon, and good evening to all of you. Thanks for attending the webinar, and look forward to having engaging discussions with all of you. I am Sridhar. I'm the product manager for Glovius. I have over 13 years of experience in building software products, and have been working as the product manager for Glovius for the past 5 years. Today, we notice that more and more companies are currently digitalizing their solutions and digitizing their processes, CAD models, and those dealing with hard engineering data are still dealing with a variety of tools, reports, and 2D drawings without leveraging the technological improvements that we are noticing in the consumer space, like the adoption of mobile devices or the need to support multiple platforms. Tom had earlier stressed on some of the key aspects of visualization from digital transformation perspective, namely the ease of use, the ability to work on multiple platforms, and the efficacy of such a solution. Glovius, our multi-platform visualization tool, precisely addresses this. It's built on modern technology stack to enable your teams leverage engineering data, especially CAD data, to view the files, analyze them, and take faster decisions based on 3D digital models. As Glovius apps follow modern UI principles, it's instantly familiar and can be quickly adapted for different use cases that might arise in an enterprise. And it can be adopted by all downstream users, including those in the extended enterprise, vis-a-vis offshore, offsite project teams, as well as suppliers. So as more and more enterprises adopt a variety of devices, any digital transformation solution needs to be able to leverage these platforms. Glovius is available on all platforms of today, for example, Windows, mobile OS such as iOS and Android, and basically any device that runs a modern browser. The main advantage we see from customers adopting our solution is taking decisions based on 3D component designs instead of a flat layout artifact like images or 2D drawings. As the solution is highly configurable, we can quickly create self-service apps that are tailor-made and applicable for a specific workflow and use cases to handle collaboration and quick analysis of such 3D design data. As industry moves forward with the standardization of data exchange formats and use cases, our solution also supports these formats and the said use case. So a majority of our users are from manufacturing, automotive, and aerospace industries. At a broad level, they use Glovius as a default application to view the different types of 3D design data that they receive and work upon, either from their OEMs or their suppliers. Leverage the inbuilt tools that are available in Glovius for part and assembly analysis and collaborate on the go. Our real-time notification system helps them stay connected with their teams and directly collaborate on the 3D design data. With this, I would like to quickly jump over to a brief demo of Glovius and then get back to the slide deck. So as we have mentioned earlier, Glovius supports almost all different types of 3D CAD formats. For example, you can use Glovius to open CATIA, Pro-E, NX, Inventor, Solid Edge, SolidWorks, Step, IGES, and JT, and so on and so forth. Apart from the 3D geometry, we also support the associated metadata of the file. For example, the annotations, which Tom also talked about in detail, the PMI information, as well as the attributes that are associated with the file. Apart from this, we also quickly compute the most prominent dimensions of the component, the attributes of the component, so as to quickly, so that the user quickly figures out the bounding box dimensions or the volume and the mass values instantly the moment he opens the component. Along with this, we can also apply various visualization filters like color or transparency effects so that you can better visualize your files and analyze them faster. We also have a variety of purpose-built tools to quickly analyze your parts and assemblies. So one of the most important and widely used tools is the thickness analysis tool. So this tool helps you to analyze the material distribution of a component. This is especially useful for if the component is being manufactured using casting processes, and you can figure out the various values of thick and thin regions in the component and thereby try and optimize the design, see the fitment particular component for the process. Similarly, we also have the draft analysis tool that can be used for quickly figuring out the angles that the different surfaces make with respect to the pulling direction. This is typically used for injection molding processes and helpful for manufacturing plastics. We also have tools for checking the structural integrity of a component. So if you have an assembly that you receive from your suppliers or your team, and you quickly want to figure out whether the component has been assembled well, all you need to do is open in Glovius and compute the collision detection, so that you get a result of the components that are intersecting, the components that have a certain clearance, as well as those having contact joints with the neighboring component. The third main important portion of our application is generating 3D reports. So we can generate a wide variety of reports, be it PDF or even images. So we can generate BOM reports, be it either PDF or CSV, based on different parameters like part level, assembly level, or even the product structure itself. We can generate a 3D PDF report for archiving use cases or sharing the files as artifacts. We can create high definition images that you would require for using in marketing collateral and other such usage scenarios. The main export format that I would like to highlight is the 3D HTML format, using which you can create a self-contained browser-based sample. So what it essentially means is you can open it up and view the file without having any associated software. Most of the computers today have a standard browser installed, so you can use this particular file and view the 3D contents along with other attribute information, PMI information, and also generate the BOM report. So now I would like to go back to the deck and showcase a bit about our customers. And as you can see, most of our customers are from automotive, manufacturing, and aerospace industries. They are either OEMs or Tier 1 and Tier 2 suppliers. So some of the highlights of how our customers use Glovius and the significant advantages that they reap out of adopting such a solution. The advantages vary from enabling 3D access to various teams, to reducing the software CAD licensing costs, or to generate quotes because of the ease access of the 3D digital data. With that, I end my session and look forward for your questions. Now I would like to hand over to Jaco Lagerwey. He is from BRINK and one of our marquee customers, and would provide more context on adapting a CAD visualization tool like Glovius. Over to you, Jaco.
Thank you, Sridhar. Good day to everyone. Welcome. I firstly want to introduce myself briefly. My name is Jaco Lagerwey, and since the year 2000, I am working for BRINK Automation in the Netherlands. And BRINK Automation is part of the BRINK Group. The BRINK Group is founded in 1963 and is a manufacturer for the packaging industry for the highest quality, fast-running injection molds for buckets, pots, cups, and lids. Since 1977, we also built automated systems or machinery for the packaging industries. And we have a broad experience in the food, paint, and chemical industry and flower pots. The business unit I am working for designs, builds, and supplies customized systems for product handling. And the core business for us is in-mold labeling. That in-mold labeling is a process where pre-printed label material, polypropylene foil, is placed in the mold cavity automatically by our systems, and then during injection of the hot plastic material in the mold, the label merges with this material, and together they take the shape of the mold during the cooling stage. That's when the product hardens and you get the final package, a product with a label included. For the 3D design engineering in BRINK Automation, we work with Autodesk Inventor, and we have this software connected to Autodesk Vault. And the Vault is a software for data management and collaboration. Since 2016, we started to work with this Autodesk Vault, and it helps the designers and engineers to organize and manage their product data and engineering processes in a single central location. Our manufacturers and our suppliers are used to work with step files. Step is a file extension for a 3D graphic file used by CAD software, and Autodesk Vault can automatically generate step files, which then can be easily downloaded. And we were searching for a CAD Viewer with which everybody in BRINK automation can open and review easily the 3D files that were generated through the Vault client. After trialing different CAD viewing software, we found out that Glovius software would be the one which is most suitable for our needs. We found out it is fast, it opens fast 3D files, it's user-friendly and stable, and it's all at a very affordable price. Glovius is used to review the 3D files and to investigate them. We can now easily and fast open and review shared 3D designs, not only on our work floor, but also in our purchasing, in our sales, in our service department. They all have big benefits by using Glovius. Working with Glovius has made our work floor, our assembling department, paperless, and also has given our sales department the opportunity to open and review third-party 3D files, and helps our purchasers to provide information needed for our suppliers or manufacturers. With the Glovius software, one can take accurate measurements, make section cuts. You can hide or show elements, parts in an assembly. You can search for components in an assembly. So yes, overall we are very satisfied with the software. It opens fast. It measures in assembly and in parts accurately. You can hide and show components. You can create section views, isolate sub-assemblies. You can export 3D PDF files, export PDF of the bill of materials with images, and this is what we use for our service when a customer is in need of some part, and he wants to clarify to us what parts he wants to order. We just share the 3D PDF of a part of our machine, and in that way our customer is sure, because of the visualization, that he orders the correct parts. Yeah, overall, to my opinion, not only the software but also the team behind Glovius is a great pleasure to work with. And yeah, so far my story. I want to thank you for your attention, and back to you, AJ.
Thank you so much, Jaco, for the insights. Thank you, Tom and Sridhar, for your presentations. We are now open for questions. Please enter your questions or comments in the questions box in your GoToWebinar console. Okay, so we do have some questions here. The first one is, our customers are still requiring us to use native CAD software, and it is expensive. Is there any way to get out of this requirement? Maybe I would. Yeah,
I think that one lands in my court. This is Tom, and okay. Unfortunately, in the short run, probably not. Your supplier requirements are usually built into a contract, but a good viewing solution like Glovius should be able to reduce the need of native software. You'll still need some seats to communicate with the customer, but it should help out with your internal use. In the long run, we would recommend you engage with your customer and work towards reducing or eliminating that requirement.
Okay, thank you, Tom. The next question is, so Glovius is used for creating BOM alone, right? Is the question. Sridhar, you would want to take that?
Yeah, sure. So Glovius can be used for a variety of purposes. So BOM reports is one such artifact that can be created using Glovius. So we also can use Glovius to create 3D PDF reports or HTML reports or even the plain old PowerPoint reports. So BOM reports, I would like to say, is just a portion of our report exporting capability.
Okay. There are two questions on making modifications to native files. So is Glovius capable of making minor modifications to native models? Or is it possible to edit or modify existing models?
Yeah, sure. So that's a very good question as well. So our main focus has been to provide a visualization tool, which essentially means that we only have read access to the model, and we don't have any mechanism or tool to edit the 3D geometry of the component within Glovius. The design has been intentional in the sense that most of the downstream users very less of the editing tools of or need to edit the geometry of a 3D component.
Okay. Yeah, thank you, Sridhar, for that. I think the next question is for Tom. Are the top requirements that you have listed all that we need to look at while selecting a good visualization solution?
Short answer is no. We created that list. What I chose to present was based on experience with clients, but the reality is you need to look at what business problems, what requirements you're trying to solve. So I'll give you a simplified process of how to go about selecting technology. You need to analyze your current situation, what processes you're doing, what do you need to go forward, or where do you think you want to go. Then you start looking at technology that can support that. So in the case of visualization, you'd identify the kinds of features that are important to you, whether it's markup or being able to view certain types of files, to be able to analyze PMI data, come up with that list. Then you start looking at technology, you do a benchmark, select your solution, and implement. Obviously, it's more complicated, more detailed than that, but that's from a high level, the best practice way to go forward.
Perfect. Yeah. Thank you so much, Tom. The next question comes, does Glovius integrate or support integration with different PLM tools?
That's a very good question. So I will take it up, Ajay. So we have existing integration with the prominent PLM tools like Innovia, Windchill, and Aras. We also have developed custom integrations with other IT infrastructure, like, for example, SharePoint. However, we do realize that many of the organizations still have custom solution and archaic infrastructure. So to handle such scenarios, we also have developed a modern technology stack-based implementation consisting of RESTful and JavaScript APIs and touch points with those system, and the solution can be deployed with a very quick turnaround time. Moreover, we also have SDKs for our mobile app, so those can be integrated into specific use cases of an enterprise solution.
Yeah, great. Thank you, Sridhar. Okay, the next question is again from a digitization perspective. What are some of the digitization use cases for engineers, for engineering data?
Sure. So again, I'll take it up, Ajay. So there are a variety of use cases and benefits when you digitize 3D engineering data. The most obvious benefit would be that it would democratize the adoption of 3D CAD data for all the downstream users, instead of it just being consumed in the engineering departments. With such a solution, your QC inspectors, manufacturing engineers, costing experts, integration engineers, shop floor technicians, and many more will have the ability to work on the product data and take faster decisions. So because we have the solutions that can be either, we also have solutions which are cloud and on-premise based solutions. So the security and those aspects that a typical enterprise would be wary of are also covered. So the typical redundancies in terms of dependencies within the various departments. So some department has to approve to get access to the 3D design data, or can also be automatically removed by setting permissions based on custom rules and handle such scenarios as well. So to give you an example, some of the use cases are if you want to move away from 2D drawing sheets, and I think Tom also mentioned this in his presentation, and completely use 3D engineering data to provide information to your enterprise users. That is one of the use cases. You can also use our on-premise or cloud services to automate workflows. For example, comparing data sets and or generating 3D reports, so that the moment you are in office, you get a detailed comparison result of all the components and the design iterations that have been checked in the previous night. You can also leverage the power of cloud to enable communication in 3D. So that's something which using our mobile app, you'll be notified about any comment or design review that has been added by your team or your supplier. So you're always in the know, and you can always carry your entire digital design repository with you on a single smart device.
Okay. Thank you, Sridhar. We'll take a couple of more questions. The next question is, how is PMI information of a particular component transferred to Glovius? Either it will read the existing 2D drawings and integrate itself, or should someone input the PMI information into Glovius?
Yeah, so that's a very good question. So, as we see, more and more companies they are shifting away from using 2D drawings to directly using markups and such tools in the CAD application to provide more and more PMI information directly into the 3D model. So Glovius is really helpful in such scenarios wherein you have existing system in place in which you have the 3D design data with PMI data. You'll be able to easily visualize it directly in Glovius without the need of the original CAD authoring application.
Okay, thank you, Sridhar. The next question is for the compare tool. I think Tom also touched on that. The compare function looks like it would be useful to our company. Our current viewer can only compare drawings. What should we do?
Okay.
Maybe Tom and Sridhar.
Yeah, the compare capability, especially where you can assess changes in assemblies, see components added and removed, is a very exciting capability. My suggestion would be first check with your current viewer supplier, see if they're moving ahead with bringing that capability online. If they're not, or it's very far out on the roadmap and they can't meet your needs, then you need to develop a business case to see if it's worthwhile to add a new tool. That compare and the cost of change in most companies is huge, so it should be a straightforward business case to justify it. If you can follow along the basic process that I described, analyze your process, identify where you want to go, look for technology that can support where you want to go, do a benchmark, select and implement. It is a high-level process. You can also listen to the replay of this if you didn't catch the details. I'm talking pretty fast on that. And certainly you can either reach out to HCL or SimData. We'd both be very happy to help you with that, assessing that problem.
Thank you so much, Tom. I guess we are on the time right now. We'll take just one last question. The question is best practice to keep synchronized 3D PDF. When original CAD file is updated, user exits to trigger conversion upon save. Batch software to watch for changes and then generate a JT or 3D PDF file?
Yeah, so this would be a pure heuristic-based mechanism that we already have in place. So I think the questionnaire himself has suggested a number of parameters based on which we need to sort of trigger the process. For example, the change in a CAD file or the change in the revision of a particular file, or so on and so forth. There can be many more parameters. For example, adding a review comment or adding a CAD data artifact, for example, adding a BOM report or a 3D PDF document and associate it with the original CAD file can also be a trigger point. So I would say the heuristic would depend on multiple scenarios, and we need to handle them on a case-by-case basis.
Okay. Thank you so much, Sridhar. I think we are on the dot. We hope you enjoyed the webinar. If you have any more questions, feel free to write to us at support@glovius.com. You can also visit the Glovius website at www.glovius.com for more information. Thank you again for your time. We will send a follow-up email with the link to the recording so that you can refer to it. Thank you so much. Have a good day. Bye.